Now, if we had drawn a perfect circle using, of course, a protractor or some efficient means, from the center of the circle to each part, here's if I did this to this one, this to this axis here, this to this axis, they should all be ideally equal. Okay, and then mathematically speaking, from the center of the circle to the outer rims over here, these are the radius. So it's radius, radius, and this should be equal no matter which side it's extending to. Now, over here, the curve is the arc length. And so what we say is that the radius is constant, right? Because it's never going to change from the center of the circle to the outer rib. But the arc length is what's going to change depending on the angle. Now, the point or the angle at which the arc length, and the arc length would refer to the orange over here, where the arc length is equal to the radius, we call that exact point in time a radian. So the angle at which the arc length equals the radius, this angle, I should say more specifically, this is the radian. I'm going to draw the connecting arrow over here. Now that's not always going to be the case, but there is a point in time where the radius and the arc length are the same. And so that angle can be found by dividing the arc length by the radius. And the exact measure of 1 radian, we say 1 rad, is about 57.29 degrees. I mean, that's the exact value. But why switch from degrees to radius? So this is another angle measurement. Well, what it does is it often simplifies and contextualizes calculation. Again, the main point of a radian is that we can give angles which are normally in degrees, which are kind of arbitrary. I mean, we don't really know what that means in terms of an object and how it's moving. And we can turn that degrees into some real, actual numbers. And this is ideal for when you're calculating objects going in circular motion in physics, for example. Lastly, we measure radians in terms of fractions of pi, and that's because they're derived from the entire circle, right, which has a value of pi. That being said, we say that 1 pi radian is equal to 180 degrees and 2 pi radians is equal to 360 degrees. And with these ratios, we use these as the real control on how we convert from degrees to radians and radians to degrees. So when we're converting from degrees to radians, we take the number of degrees that was given to us by the question and we multiply it by the ratio of, for every pi rad, it's 180 degrees. And what I'm going to do is I'm going to insert just pi radians over here. Now, if we wanted to go the other way around, well, it would be the opposite. You would have the number of, you could say pi radians, multiplied by 180 over pi rad. And so this one over here would be from radians to degrees. And when would you need that? It really just depends on the question at hand. So let's say I'm asked to convert the following to radians. So I've got 90 degrees here. This is the angle given. So it would be 90 degrees multiplied by pi rad over 180 degrees. Our degrees would cancel out. The 90 and the 180 would simplify. You would divide each side by 90. And that would leave us with pi over 2. Because 180 divided by 90 is 2. And so this would be the conversion of 90 degrees into radians. Now, let's say we do 330. The same thing is going to be done as we did previously with the 90. We're going to go 330 degrees multiplied by pi rad. Now, one thing I do want to say is that often textbooks don't include the rad part, so they just write in terms of pi's. So you might just see pi, kind of like this one over here. And the same thing is going to hold true. The degrees are going to cancel out. And this ends up simplifying into 11 pi over 6. So in our next examples, we're going to convert the following to degrees from pi radians. So, like we mentioned in the formula before, we're going to take the amount given in radians, and then we're going to multiply it by 180 degrees over pi radians. And what that's going to do is that is going to cancel the pi out. And then when you plug this into your calculator, you're going to get 270 degrees. We do the same process for the 7 pi over 6, and I realized I put a 2 over here, but it should be a 6. We're going to quickly correct that. And again, we do 180 over pi because that is the ratio. The pi's cancel out. And then we are left with about 210 degrees.